Good afternoon, ladies and gentlemen. Oh, good afternoon, Ichikawa-san. Did you hear me?
Yes, I can hear. Good afternoon.
Okay, excellent. Thank you very much for coming in. You are our guest speaker for today for our webinar. Very happy to have you over here. We would like to welcome our friends, our directors of RITA over here. Dr. Charan. Thank you, Dr. Charan coming in. อีกคนที่สมบูใครวะ
คุณชาสวัสดีครับโอ้ครับ
สวัสดีครับคุณสมบูใครวะ
น่าจะเป็นสมาชิกท่านอื่นที่สนใจเข้ามา
Mr. Anils, can you introduce yourself?
Yes, thank you. Good afternoon. My name is Anil Skaria. I am our factories in Songkla, Hatyai. We make baby products.
I can't hear you very well. Can you repeat again?
Yes, my name is Anil Skaria. Our company name is Thai Made Baby Products. We are situated in Songkla, Hatyai.
Oh, okay. So thank you very much for coming in to join us in RITA.
Thank you.
Hope we can continue and our support. Anything that RITA can help you in your to be success. Let us know. We have a team of professors over here, quite a lot of professors over here. Okay.
Okay. Thank you.
Thank you very much. Good Anil.
Thank you.
อาจารย์ทิตินัน welcome อาจารย์ทิตินันสวัสดีครับอาจารย์ทิตินันครับ
สวัสดีค่ะ
สวัสดีครับอาจารย์ครับคุณจักราอาจารย์อิทธิพลครับ Good afternoon ครับอาจารย์อิทธิพล
สวัสดีครับสวัสดีครับ
สวัสดีครับ
ขออนุญาตปิดกล้องนะครับพอดีครับ
เชิญครั
ขั
บบ
รถอยู่นะครับขอบคุณครับ
คุณวรชัยครับโอ้ซัมซุงอยากซัมซุง who is joining us from Samsung SM would you please introduce yourself Samsung SM and คุณจุธรัตน์ welcome to our webinar
สวัสดีค่ะ
สวัสดีครับคุณปราณี
สวัสดีค่ะอาจารย์
สวัสดีครับคุณปราณี introduce yourself please we would like to see your beautiful face สวัสดีครับคุณสวัสดีครับ
ค่ะ สวัสดีค่ะ อาจารย์ปานีนุ่นหนูนะคะ จากสาขาเทคโนโลยียางและโพลิเมอร์คณะวิทยาศาสตร์มหาวิทยาลัยอุบลราชธานีค่ะ
สวัสดีครับอาจารย์ปราณีโอดีใจจังที่เจอกันเอง
ดีใจเช่นกันค่ะ
สวัสดีครับเรื่องมือครับมูเซียวมีใครไหมครับไม่มีเรื่องเลยนะครับ Okay
Now 15 participants.
So we have 15 participants for webinar. So it's about time. So Ichikawa-san, you can start your webinar. Okay. Let us welcome Ichikawa-san for his webinar. Thank you very much.
Thank you. Can you see my presentation?
Yes.
Okay. So I will start my presentation. I have been involved in natural rubber research, development, and actual production for over 30 years. I became involved in natural rubber through an encounter with the late Professor Tanaka, who was a leading researcher in the structure research of natural rubber.
Yes.
Professor Tanaka developed the purification method to study natural rubber structure. We utilized this method and developed deproteinized natural rubber, DPNR, and commercialized DPNR rubber glove and applied DPNR to other uses. My first connection with Thailand was in June 1993 when I visited Mahidol University and Chulalongkorn University with Professor Tanaka. After that, I conducted the industrial production of DPNR latex in southern Thailand. After that, I continued to build connections by conducting joint research with professors at university in Thailand. Since 2019, I have been involved in the production of natural rubber block rubber at Sumirubber Thai Eastern Corporation in Udon Thani. Today, I would like to talk about the DPNR, which was my first experience with natural rubber and the reinforcement of natural rubber with cellulose nanofiber, which I believe will become an important material in the future. Lastly, I would like to talk about what we are currently working on our processing factory and what I think is necessary for the natural rubber industry. First topic is DPNR. I will make a presentation following this content. This drawing shows the mechanism of the deproteinization of natural rubber. This rubber particle and protein are attached to the surface of rubber particles or dissolved in the serum. Proteins are decomposed by added enzyme and replaced to surfactant. This treated latex is then diluted with water and DPNR is obtained after eliminating the decomposed protein through centrifugation. This scheme shows the actual production process of DPNR latex. We can use field latex or concentrated latex as raw material. Obviously, cost-wise, field latex is more advantage. The degree of deproteinization depends on the activity of enzyme and the dilution rate before centrifugation. We use high active proteolytic enzyme and dilute treated latex to 10 to 15% DLC before centrifugation. This table shows the specification of our DPNR latex. We have two grades of DPNR with different nitrogen content. The nitrogen content is measured by Kildare method. Nitrogen content is used as index of residual protein quantity. Later, I will explain allergenicity of DPNR latex. Viscosity increase with deproteinization and enough mechanical stability is obtained by selecting the surfactant. At the same time, sensitivity to coagulant is adjusted by selecting surfactant. This figure shows the film thickness of DPNR latex and high ammonia natural rubber latex at different coagulant concentration. DPNR latex has almost the same sensitivity to high ammonia natural rubber latex. Next, I show the summary of a feature of the film obtained from DPNR latex. Film color of DPNR is transparent, odor weak, water absorption very low, modulus low, chemical modification, type 1 allergic negative, resilience excellent, creep low, electric resistance very high. Here I show the IR spectrum of DPNR and NR. We can see the difference at 3300 wavelengths. NR shows strong absorption, but DPNR does not show absorption because proteins are decomposed and removed. We can differentiate DPNR from NR. Here I show the allergenicity of DPNR latex. We measure the allergenicity of extract of DPNR latex film. This table shows the level of latex protein allergenic through RAS inhibition immunoassay using latex allergy patient setup. We can see DPNR has very low allergen level compared to normal NR latex. Our normal DPNR has average 6 and high grade is not detectable, while normal NR average about 800. And we also measured antigenic protein content from the result of deep assay. Antigenic proteins could not be detected from DPNR latex film. DPNR latex can be used for many applications which utilize its feature, especially low allergenic and softness. We apply DPNR these purposes. Here I list the characteristic DPNR graphs. DPNR graphs shows enough tensile strength. The tensile property are very well beyond the requirement of ISO standard. DPNR graphs shows lower modulus than conventional NR graphs. DPNR graphs is soft and more comfortable to wear. DPNR graphs show low extractable protein content without special washing process. And DPNR graphs clarity to the film and show less odor. This figure shows stress strain curve of DPNR graphs and NR graph. DPNR graphs provide excellent softness compared to normal NR graph with maintain the tensile properties. I will talk about allergenicity of DPNR graph. At first, I talk about extractable protein content. This figure shows the residual extractable protein in commercial graph. The EP content was measured by ASTM standard method that is modified lowly. As you can see, EP content of recent commercial graph are well controlled to less than 100 microgram per gram. Our DPN graph are found to be in the same EP level. However, please take a look at the next slide. This figure shows the allergenic protein in the same commercial graphs. Antigen was measured by leap assay that is latex ELISA for antigen protein. And allergen was measured by RAS inhibition immunoassay. From this figure, surely powder-free graphs have low antigen or low allergens, but in our DPNR graphs, allergenic protein was not detected at all. This graph shows the relation between extractable protein content and allergen protein content. Theoretically, extractable protein quantity should be proportional to the allergen protein quantity, but in the case of DPNR, allergen proteins extremely low against the extractable proteins. This diagram is easy to understand the said relation. Now DPNR is the same EP level as NR. But allergenic protein is not detected in DPNR while it is high detectable in NR. Next, I will show the result of clinical testing. One is use testing with one finger of latex glove for one allergenic patient. This test was carried out in Nagoya University School of Medicine. In this case, DPN glove, the allergenic reaction was negative, while normal NR glove showed positive. The other is scratch prick test with 23 allergenic patients. This test was carried out in total of 13 domestic university or national institutes. As you can see, our DPNR has excellent effect to patient who is allergic to protein. Extraction of DPN graft showed positive rate by less than 10%, while extraction natural graft show about 80%. These results show that DPNR is effective to prevent NR protein allergy. Next, I will talk about DPN solid rubber. We prepared DPN solid rubber from DPN latex produced by our standard procedure. DPN latex was coagulated with dilute to formic acid and dried. Low DPN solid rubber has low gel content and low nitrogen content. But other properties do not show clear difference with natural rubber. We evaluate the vulcanized rubber property of DPN with these rubbers. Here I show the cure characteristic of unfilled compound of DPNR, NR, and IR. DPNR shows slow curing speed compared to NR. Tensile property were well maintained and show lower modulus than NR. Next, I show the cure characteristics of carbon black filled compound of DPNR, NR, and IR. Curing speed was not so much different between DPNR and NR in case of carbon black filled compound. Tensile property were well maintained and show lower modulus than NR, but tear strength of DPN was lower than NR. Tear strength was close to tear strength of IR. Here I show the tangent delta at 0 degrees Celsius and 70 degrees Celsius of various nitrogen content of DPNR and NR. DPNR shows that higher tangent delta at 0 degrees Celsius and lower tangent delta at 70 degrees Celsius. These properties are good for tire tread. This is the creep rate at 100 degrees Celsius of EV system cured DPNR and NR. DPNR shows better creep resistance than NR. The better resistance of DPNR due to reduction of in-known rubbers. Here I summarize the solid rubber features. And this is a summary of DPN. DPN latex products show quite less allergenic potential according to the measurement of allergen and antigens. DPNR latex products have softness and more comfortable to wear as gloves. DPNR shows that the rubber retains the strength of natural rubber and also has good resistance to creep, deformation, and lower damping properties. I will move to next topics, cellulose nanofiber reinforced natural rubber. I will explain following this content. At first, I will talk about cellulose nanofiber. We can get cellulose nanofiber decompose a cell wall from a plant tissue. Cellulose nanofiber has high strength and low thermal deformation and low weight, and it's environmental friendly material. To develop tire compound, we improve, we have to develop techniques like utilizing the characteristic of CNF, high rigidity, low specific gravity, and natural resources. Then we can improve tire performance and promote the development of elemental technology necessary for manufacturing with low dependence of oil resistance. And we can get CNF from many kind of plant, from tree to cotton and bamboo. We can get from many plants. Here I will explain preparation method for cellulose nanofiber and rubber composite. Firstly, I explain a method for producing cellulose nanofiber. As I told, CNF can be obtained by losing plant tissue into small pieces. We can get CNF using equipment with physical stress, like high pressure homogenizer, grinder, to screw extender. We can get CNF by chemical treating like tempo oxidation. And some bacteria produce cellulose nanofiber also. I show the example for preparation method. One is grinder. Using grinder, we can get CNF through the grinder slit. And in our study, we use a two-screw extruder to prepare CNF, changing raw material condition and equipment conditions. We supply wood pulp to two-screw extruder. After through a twin screw extruder, we get CNF. Next, I show the composite method of CNF and rubber. If we try to make composite at dry condition, CNF cannot be dispersed in rubber because strong intermolecular interaction. We can get like this morphology, still remains a fiber. So we use wet blend method. We make composite CNF slurry with rubber latex. We mix, then coagulate and dry. Then we can get rubber CNF composite. I'll show you actual process from slurry preparation. We put the CNF put into water and stir stir and disperse into water. We have to control solid content because water become very viscous. Then we apply solid content 0.5 to 1%. After getting CNF slurry, we mix with latex and stir, then coagulate and wash and dehydrate and dry. Then we can get CNF and rubber composite. After getting a composite, plasticize the composite with 2 roll mill or internal mixer. Then we added a compounding agent and vulcanize agent. After mixing, then vulcanize at 150 to 170 degrees Celsius. Then we get CNF reinforced rubber vulcanized. We change the parameter, raw materials, process, and formulation. Then we study the effect of these parameters. At first, I show you the result. We use unbleached kraft pulp and bleached kraft pulp. In case of bleached kraft pulp, it contains no lignin, but in case of unbleached, we get lignin content 5 to 7%. This is the SS curve of CNF reinforced rubber. NUKP, this is contain lignin. And NBK is no lignin. Natural rubber vulcanized reinforced with NUKP delivered CNF has the same elongation at break, but higher rigidity and higher strength. Lignin affects the rigidity in this case. Next, I show the effect of difference of different defibrication level. We change the defibrillation load, low and high. In case of at low load, many undefibrillated remains. And in case of we use high load, undefibrillated remain little. This is the SS curve of CNF reinforced rubber. In case of even CNF, higher modulus and have high elongation at the break. And defibrillated fraction are the starting point of disruption. So, tensile properties differ. This is in case of NUKP, and next is NPKP. This is after bleaching kraft pulp. We can get the same result with NUKP. Next, evaluate the influence of CNF amount of introduced on rubber properties. we put 10 phr, 20 phr, 30 phr. Result is this. Increase the amount of CNF introduced improves the elastic modulus. However, it is accompanied by the decrease in elongation at break. So, it is necessary to control the amount of CNF introduced by considering the balance between rigid and fracture characteristic. Next, I show you the evaluation to know the influence of CNF fiber length on rubber reinforcement properties and mechanical anisotropy. After cold to roll mill or extruding CNF oriented this direction, so we check the effect of this orientation. And we use two kinds of CNF. One is standard length CNF, another one is shorter CNF. Here I show SS curve of rubber itself and put shorter CNF and standard CNF. And if we put the standard longer CNF, we had high modulus. And if we see the anisotropy, orientation, direction, and other direction, in case of longer SCNF, it has difference. But in case of short fiber length, the direction, even though different direction, easter is not so much different. So fiber length has a strong influence on the stiffness rubber, and mechanical anisotropy becomes apparent as the fiber length increases. I explain when we put the CNF to natural rubber, but here I show you the difference when we put CNF natural rubber and SBR. In case of natural rubber, we can see the effect from 5 PHR, but in case of SBR, we can see the effect of CNF from temperature. The amount of CNF introduced at which the reinforcing effect begin to appear varies depend on the rubber. Here I summarize our testing result. I didn't explain about the interface control, but rubber CNF interface affect fracture properties. I think this is important matter for this development. Next, I want to move to final topics, current issue for natural rubber industry. Natural rubber is absorb the CO2 and wood is used for so Is natural rubber really sustainable material? Just now I showed, says rubber trees absorb a lot of CO2 to grow and produce latex, which end up in thermal recycling to CO2. From this circulation, natural rubber itself is a sustainable material. But actually, deforestation is taking place for natural rubber plantations, which has a significant impact on the environment. And labor issues yield vary by region and have a significant impact on the income of smallholder and tappers. They may also be placed in harsh working environment. And rubber disease, the spread of default disease means that output will fall. The disease is spread in Indonesia, Malaysia, and southern Thailand. And rubber products has smell issue. Block rubber made from capram has a strong odor and cause odor problem. The problem need to be resolved for better human life and environmental sustainability. Like this situation, many challenges must be addressed and resolved to create and maintain a sustainable supply of natural rubber. Environmental issue, social issue, economical issues. One is global sustainable initiatives. The Sustainable Natural Rubber Initiatives, SNRI, established in 2014 as a member voluntary and collaborate project under the International Rubber Study Group framework. The Global Platform Sustainability Natural Rubber, GPSR, in 2018, led by major Thai manufacturer GPSR, was established as an international platform for sustainable natural rubber supply chain. This one also for sustainable, equitable, and fair natural rubber value chain. GPNS is setting up an assurance model based on a risk-based approach. Members act on a shared responsibility framework with 3 pillars: share investment, value transfer, and global setting, and knowledge and data sharing. And actually, the policy component for framework are spread across 8 themes with commitment to currently, companies and organizations are working to build a joint natural rubber value chain based on the GPSR framework and to enhance the sustainability of natural rubber by their own activity based on SINR. From here, I will show you our activity to sustainability. Sumirubber Rubber Group established a sustainable natural rubber policy. This is a sustainable natural policy framework of Sumirubber Rubber Group. Sumirubber Thailand Corporation also conduct activity for sustainability of natural rubber in accordance with the policy of the Sumitomo Rubber Group. Our activity for today, I will talk about our activity for sustainability. These three matters: development, raw order natural rubber, environmental measures at factory, upstream support activities. At first, I explain about order natural rubber problem. The problem need to be resolved for better human life and environmental sustainability. From the material to product, we have to improve. For this purpose, we developed the less smell rubber. At first, we investigate the cause and actual process giving natural rubber odor, and to find the improvement method for reducing bad odor annual at the factory. I show the process of from plantation to our final product. In our factory, we storage the capram and wash and dry, and we make final product. During this process, to investigate the cause of odor and find the improvement method for reducing the odor. I show you the source of odor in commercial TSR 20. One is short chain fatty acid. This is generated by during storage by spoiling, and these chemicals generate by heating. So substances which cause odor was generated during storage and drying process. We analyze a quantity of materials using HSGC mass. After getting this result, we set order index using this formula. We use this olfactory thresh value for each chemicals. Then we can get good relation with our feeling and this index. This result shows effect of storage time of capram at plantation. If we keep the capram a longer time, but odor is generated during storage period. But we cannot control this part. Next, I show you the odor index in a factory process. From the receiving to final product, we measure the odor index of each stage. After receiving, after storage, after wash, after drying. From this result, storage of capram in factory and dry process main cause generating but odor. Next, I show the effect of storage time of capram before production. After receiving capram from plantation, we keep the capram 1 day to 4 months. From this result, severe odor was detected at the stockyard in factory, mainly from long storage period. Next, I show effect of drying temperature in drying process. Heating at high temperature in drying process, like 135, also was a cause of bad odor generated NR. So we cut and wash capram just after receiving from the plantation, and we try to reduce the drying temperature. Then we can lower the odor level. We succeed to get low odor NR through production process improvement. At the plantation, we cannot control this part, but controlling our storage and drying condition, we can produce natural rubber with lower odor. If we can collaborate with farmer, less odor natural rubber we can produce. Next, I will explain environmental measures at the factory. At one is air pollution treatment. We use chemical wet scrubber for smell treatment exhaust air. We set the two scrubber, and one is quencher, and next is scrubber using different chemicals. If using this equipment, we can reduce the odor from our exhaust. And usually we check once a week, we check the community around the factory distance 1 to 3 kilometers, and check the smell level, and we can keep the lower level result controlling our exhaust treatment. And next, wastewater treatment. In our factory, we use 2,000 cubic meter water per day. So we have 3 water treatment systems. And we treat all the water, and we reuse all the treatment water in our production process. We manage our operations so as not to affect local communities. and upstream support activities. One is farmer education. We have been conducted educational activity for smallholders. And another activity is farmer survey. We conduct a farmer survey to know their situation and to confirm whether the sustainable natural rubber policy is being followed. I summarize these last topics in order to continue to using natural rubber as a sustainable material. It is necessary to address environmental, social, and economic issues. In order to carry out these measures, cooperation from upstream to downstream is necessary. Most natural rubber is produced by smallholders, and the support of smallholders is important. I expected research and development to improve sustainability through industrial and agricultural technology. Professor Tanaka received the ACS gold medal and contribute this paper to RCT. Although Professor Tanaka's research has enabled us to understand many things, there are still many things that are still unknown. Natural rubber is an important agricultural product for Thailand, and I hope that Thailand will continue to develop its technology as a producing country, including the industrial effort. Thank you for listening.
Excellent. Ichikawa-san.
Yep.
You know, your presentation is very useful. I think we have quite professors joining this conference. They hearing what you're saying. 3 of your projects are very useful for rubber industry. The first one, you talk here of DPNR. I like to ask you one question. You are talking about how to get DPNR
Yep.
by using the M sign.
Yep.
And the result showing very good excellent.
Yeah.
Whether you have already commercial this DPNR?
Yes, we commercialize in southern Thailand, and we use this DPN latex in our Malaysian rubber glove factory.
Oh, so you already commercialize this one in Malaysia glove industry already.
Yes.
Excellent. This is what they are looking for. Okay, that will be very useful for the industries. The second one, you talk about the reinforced natural rubber by cellulose microfibers.
Yes.
I saw very useful in mechanical properties after you reinforce with the cellulose microfibers.
Yes.
When you compare to normal in the tires, we reinforce the natural rubber or rubbers by carbon.
Yeah.
Okay, microfiber and all this one. When you compare that one, what is really the values? The microfibers, cellulose microfiber compared to the conventional carbon black. What's
Yes.
really the values?
Yes, in case of carbon black, we have to put 50 or high pHr to rubber. But in case of CNF, we can put only 10 pHr or so. Rubber gravity, we can make a very, how to say, low weight tire.
Low weight tires.
So we can reduce fuel consumption.
The weight, you have the advantage of the weight of the
Yeah,
tire,
yeah.
right?
Yes.
But you know, in the conventional tires reinforced, you can use the very small particle size of carbon black.
Yeah.
It will give almost very good reinforced property. Okay, why we have to looking for the microcellulose, which might be a little bit higher on the cost to produce this one. What is the value total when we look at the very micro size of the carbon black? It also get a very good reinforced properties.
Yeah. But
And
yeah,
also you can reduce the weight of carbon black as well.
yeah.
Okay, okay, and I hear you, but the weight you reduce for microfibers is not very significant compared to others, you know, in a total weight of making the tires. Okay, but it's very useful experiment. I agree with you. Thank you very much. And the other one for your natural sustainability, I think that is excellent. It's very useful for rubber industry. I heard that Thai Eastern is producing this one, and you are working with the Thai farmers and all this kind of method. You know, I appreciate, and I think many professors over here, they're also working on natural rubber. You know, I think we would like to study from you.
Yeah.
No, if we have chance, we would like to ask you to come and give a presentation again. And
Yes.
for more details, we will let you share more detail. So it will be very useful to all of us, and especially the natural rubber industries in Thailand. Okay, thank you very much. I like to hear from the floor. Ajahn, any comment from
Mr. Anil.
Mr. Anils? Any questions from you?
Yes, thank you very much. Mr. Naoya, your presentation was excellent, especially the last part of how you are doing the sustainability. As Ajahn mentioned, that it will be great that this information, if sharing to the industries, it will be very useful. Normally, if we pass through any rubber factories, it is a lot of smell coming all the areas, not only 3 kilometers, it is around 6 kilometers, a lot of smell, but you did a good job.
Yes.
But I have some questions to you regarding the deproteinized natural rubber latex. I am very much interested this one. So you mentioned this is commercially available in Thailand.
Yes.
Okay, if you don't mind, you can share your contact details so that we will in touch with you. Second thing is you shown a lot of data of extractable proteins and antigens. This is the laboratory result or the product from the commercial, or it is a result from a commercially produced any rubber product or latex product.
Yeah, I show you some is our how to say test sample, and some graph result is we get the sample from commercial.
Okay, so what I heard is that some of your results are from the laboratory, some are from the commercial product. So to adding to this question, is it all leached in the same condition, or when we use the DPNAR, we can reduce the leaching time?
Yeah.
Yeah, I think so.
I think so.
We can reduce the leaching time.
Yes.
Yeah. Okay. And you mentioned this type A and type B. the difference is the amount of enzyme we are putting into the latex?
At the moment, we use sorry.
Yeah.
Type A and type B, we use same enzyme and dilution and centrifugation process is different.
And what is the non-rubber content in your type A and type B latex?
At the moment, I cannot remember the very low non-rubber component.
It is less than 1 or it is less than
Yeah,
1 point?
Yeah, less than 1.
Okay, great. At present, this latex used for what kind of products? This DPNR latex?
At the moment, we use for rubber glove and balloon.
Oh, balloon. Okay. Just to get a knowledge about when we are comparing with the normal concentrated latex with your DPNR, what is approximate percentage of the price difference? It is 10%, 20%, 30%, 40%, approximate.
At the moment, I cannot remember, but I have to check. Sorry.
Okay, thank you.
Any question from the floor again? Okay, if there is no question,
คุณคชาคะ
have please.
จุธารัตน์ I'm จุธารัตน์
Yes, please.
Okay, Ichikawa-san, thank you very
Yes.
much for your presentation. I would like to about the I have two questions. One is about the
Wait, not
DPNR and another one is about
คุณจุฑารัตน์ please.
the carbon the nanofiber. About DPNR,
คุณจุ
can
ฑา
you
รั
hear
ตน์
me?
we cannot hear you clearly.
Hello, can you hear me?
Now okay.
Uh-oh. ได้ยินไหมคะ
Now it's okay.
Okay. About DPNR.
Yes.
Okay. About DPNR, there are requirements from the market that would like to use DPNR for other application outside of film, but they request for testing the extractable protein, not only the nitrogen percentage. So I just wondering whether you have any idea on checking extractable protein for other products. I mean, not the film. Do you have idea can share me?
In case of DPNR, we decompose
Hello.
protein.
ได้ยินไหมคะ
He is answering.
ว่า
Okay.
สัญญาณไม่ดี
Go ahead.
Yeah.
Sorry.
Can you hear me?
So
Yes.
can I help Kunjutaras for the question again?
Yes, Nong, help me please. My signal is not good. I would like
Okay.
to ask him about the testing of extractable protein
Yes.
for outside of
Yeah.
film. Yes, please.
Yeah. May I ask some question about the testing method of extractable water protein content from the final product? Do you have any suggestion of this method if we would like to test the extractable protein in the final product, but it's not like the film like rubber glove?
Not rubber glove.
Yes. Some Because the thickness of
It's
the
like the thicker.
yeah,
like the
yes.
thicker part.
We have the limitation of the product, so the method that we would like to test is not suitable with the general one. So do you have any idea about this?
One is how to say, fix the area which contact with water, then at constant condition.
Both questions are not very clear. Juntara, your question is not very clear.
Is it better to charge?
คืออย่างนี้ค่ะพี่ คือมันมีแอปพลิเคชันอื่นที่มันไม่ใช่ฟิล์ม เราอยากจะเอา DPNR ไปใช้ในแอปพลิเคชันเหล่านั้น ซึ่งมันค่อนข้างมีความหนากว่าฟิล์ม แล้วเขาอยากเช็ค extractable protein ซึ่งพอมันเป็น vulcanized หนามันเช็คด้วยวิธีแบบฟิล์มไม่ได้ ก็เลยจะถามเขาว่ามีไอเดียหรือมันมีวิธีการอื่นในอุตสาหกรรมอื่นๆไหมอะค่ะ ว่าเขาเช็คกันยังไงอะค่ะ
We have big question. You go directly personally with Dr. Ichikawa by personal later on. Can we?
Maybe I can
Okay.
maybe I can add 2 words here. Normally, there are only 2 methods to check the protein. One is ASTM or another is the EN, European method. There are the only 2 approved 2 methods. I mean, if you say if it is a thick product or thin product, this is the procedure is normally applied.
Yes.
Yeah, okay.
Okay. If no further questions, I would like to thank you very much to Dr. Ichikawa. Thank you very much for your
Thank you.
presentation. Excellent. We hope to have your presentation in future again. Thank you very much. ขอบคุณครับ
Thank you very much, Ichikawa-san.
Yeah, thank you.
Very much.